In a recent 2-minute tutorial video, we explored wavelet layers and we explored using the ExtractWaveletLayers tool to allow you to extract the individual layers as specified from your image so you could see what detail was preserved in each layer. This tool is really focused on doing visualization. It extracts the layers and then applies a stretch so that you have something that's easy to look at. There's not a lot more you can really do with those layers other than look at them, although I could see an argument where each of those layers could be used as the basis for a mask that would allow you to target certain operations towards the features that happen at a particular scale. So that might be something you could do with it. Today, I'd like to show you how you can do some of the very same analysis, but this time using the MultiScaleLinearTransform tool. Even better, when using MLT, you can do operations on those layers, and you can do that right in the context of the tool. You can choose what sharpening you want to do on specific layers. You can choose to do noise reduction on specific layers. You can remove a layer completely, or you can extract the layer that can be used for other kinds of external processing. Using MLT for image analysis is pretty handy, but it does have some caveats that you need to be aware of that can make things a little bit less convenient. Here we have my image of Malat 15, the heart of the heart, and we're going to use it once again as we explore using the MultiLinearTransform tool. And as we look at the tool, right now I have this set up in this particular case with 8 layers and a residual. So we're going to go up to a scale of about 128 by 128 pixels. And then after that, everything would go into the residual layer. Now, one thing that's kind of cool about the MLT tool is it actually has a live preview mode, which you can see down here. So why don't we engage that? Now that we have it, we can actually start to play some games. And as we play those games, we'll see some of the strengths of using this tool as an analysis tool, but we'll also see some of its limitations. First, let's do a quick exploration of what it looks like to turn layers on and off. And layers can be easily turned on and off just by double-clicking on them. So as I double-click on these, I'm taking layers completely out. And what we're seeing is a live view of that image with those particular layers removed. And no surprise, when I remove all the layers, you have a black image. When I turn on the residual layer, we have this macro view of the image. And this is important because at this large scale, you kind of have the average code value for the entire image, and you also have sort of the built-in gradients that are there. This image is going to be subtracted from the other layers, so this average value is not going to be there. That becomes important when you want to look at another layer. So let's say, for example, we wanted to look at something in the mid scale. So we'll take layer 4, we'll turn that on, and we're going to turn off the residual. We don't see anything. It's a black image. And the reason it's a black image is the code values here are very low because they've been normalized to the layers around them, and it carries no signal high enough for us to really see that. So one way to get around that simple trick is to always keep the residual turned on. This lifts up to the average code value, and now at least you can see a little bit better on what's going on. So in that particular case, so now if I wanted to go back and look at a feature that's around scale 4, I can see some of that because it's not dark anymore. It's been lifted up by the residual layer, and I can start to see what detail is in there. So that's one little trick, is to keep the residual turned on. And as you explore different layers, you can see a little bit better on what information that layer is carrying. And the other thing that's kind of cool to do with MLT is you can do an analysis of not just one layer at a time. You can look at groups of layers. So for example, if I wanted mid-scale, I might turn on layer 4, 5, and 6, and you see how that chunk of layers is really carrying a lot of the information and the larger scale elements of the image. Another downside that we're going to have, however, is the fact that when I want to look at very small scales, let's say 1 or even 2, I can't see any information. And the reason I can't see any information is the fact that It's very small in scale. It's 1 and 2 pixels in size. And to really see what's going on, I need to be able to zoom in on that image. And I can't zoom in on that image because I'm looking at a live preview and there's no zoom in there. So if you want to analyze your images in a live preview for small scales, you're going to run into a problem. Now, there is a workaround you can consider. Let's get rid of the preview for a moment. What I could do is say I wanted to look at these 2 layers, and I'm going to turn off the residual for right now. And I can take my main image, and I'm going to make a clone of it just by dragging it. So now I have a clone of the image. I have these 2 layers turned on, and I've turned off all the other layers. At this point, I can drag this over and operate on this image. The processing that's going to be done here is we're only going to preserve those first 2 layers, and all the others, including the residual, are gone. Of course, when we look at it, there's no detail because the residual isn't there, and the information that's left is very, very small code values. I can, however, do an auto stretch. And when I do an auto stretch, suddenly I can see a lot more information, and now I can also do zooms to get in and see the real fine detail. So that's a very easy workaround. If you want to do an analysis on small scales, you turn on the scales that you're interested in doing, take a clone of the image, apply this, and then you can do an STF, an auto stretch so you can see the information a little bit better, and you get a good feel for what's going on there. So this gives you an alternative way of looking at the small scale, but it also tells you something else. You can see now how you can begin to do operations on those layers. In this particular case, what we did is we extracted a couple of layers, but I can imagine a scenario in here where I've turned all the layers on, and now I decided I just wanted to create a version of that image that doesn't have the second layer, for example, or third layer, just to be arbitrary here. So with those 2 operations, I can see very simply how I can extract layers or combination of layers, or I can remove layers from the image. So this begins to hint at the idea that MLT allows you to do some very interesting transformation at the layer level. Stay tuned for the next 2-minute tutorial, which will provide an introduction to using MLT for sharpening and noise reduction.